So we're finally ready to move on to Newton's second law. And I wonder how many laws there are. I'm actually not going to tell you because that's cheating. You're just going to have to find out. But to recap, let me remind you what Newton's first law is. So another way of wording Newton's first law is the idea that if you draw a force diagram on an object and all of the forces are in balance, that is, they cancel each other out, then the object will not accelerate. And that can play out in two different ways. Either you can have an object that's sitting and it keeps sitting, or you can have an object that's moving and it'll keep going at a constant speed. Newton's second law is actually almost as simple. It says that if you draw a force diagram and the forces do not balance out, then the net force, the amount left over, the amount that doesn't balance, is equal to mass times acceleration. Now that we're bringing a formula into the mix, we've got to make sure that we define all the variables and have all the units figured out and all that. So let me show you some things. Well, I'm sure you've heard these words before, mass and force and acceleration. I might define them a little differently than what you've heard previously in other classes, especially in chemistry class. My definition, and I think a very good physics definition of mass, is a resistance to accelerations. So the more massive you are, the harder it's going to be to change your movement. So if you compare a really small guy to a sumo wrestler, the sumo wrestler has more mass because it takes more to speed him up. You're going to have to push harder. And a force is the push or pull that causes those accelerations. And for units, in physics for mass, we're not going to use grams. We're going to actually use kilograms because we're going to deal with things that are a little bit chunkier. And in chemistry, we're dealing with smaller stuff. So we're going to use kilograms here. And for force, the unit that we use is newtons, named after Isaac Newton. And for that, we're just going to write an N. Now, when I talk about the word net force, like I was saying before, the word net means after you cancel everything out. So maybe if you have a job, you've gotten paid and you notice that the amount that they paid you wasn't what you should have gotten. Well, the reason for that is because some of it was lost to taxes. So they actually have two different words. They talk about your gross pay, which is the total amount that you earned, but your net pay is the amount of money that you actually get to take home after taxes. It's the same thing here. After all is said and done, net is the amount that's left over. So if I've got a block just floating in space, and one guy pushes it to the right with 5 newtons of force, and another guy pushes it to the left with 2 newtons of force, then we would say that on this block, the net force, F net, equals 3 newtons to the right. In another similar example, if I have another block floating in space, and one guy pushes it 3 newtons forward, and the other person pushes it 4 newtons to the right, and we want to know what the net force is, it will not be 7. It's sort of like what we looked at in the previous videos. Since force is a vector quantity, we can't simply add the numbers up. We have to build the triangle out of them. Because remember, when you add vectors together, you got to do them head to tail like this. And then this yellow vector actually represents the net force. And to calculate that, we've got to use the Pythagorean theorem. So on this particular problem, if we combine those two vectors, we actually end up with a net force of 5 newtons because we do the a squared plus b squared thing. And you end up with 5 there. So let me run through a few examples of Newton's second law in action where we can actually calculate some forces and accelerations. So what I have is a 2 kilogram block that's simply falling. You dropped it from the top of a building and it's just accelerating straight down. And we already know that it accelerates at a rate of 10 meters per second, but what I want to know is on this force diagram, what's the force of gravity going to be? Well, Newton's second law tells us that F net equals ma, and in this case, the only force that's acting on this thing is a downward force of gravity. There's nothing else touching it, which means the net force and the force of gravity are the same, because the net force is coming from gravity, so we can write the force of gravity equals mass times acceleration. Now, if we plug in the information that we know that it has a mass of 2 and it accelerates at 10 meters per second, and that tells me that the force of gravity on this thing, the net force, is going to be 20 newtons. In fact, if that's true, if F net equals ma, then we can very easily calculate the force of gravity on an object. It's always just going to be 9.8 times its mass, because if you were to drop it off of a cliff, it would have an acceleration of 9.8, And then if you multiply that times mass, that would give you that net force.